Hey, welcome back to Introduction to Engineering Design. This is Module 7.4, and we're assembling a model, basically of some components that are given to you in the Canvas page. So after your quick read through this, you'll see that you're going to put together two different parts, or two different assemblies. The first is a jack lift, and the second is the Automobilox car itself. So for the first part, what I'd like you to do is to make a new folder on your desktop, and I've actually made this. You can put it on your desktop or your documents, title it Jack Lift. Go to the Canvas page and download the appropriate files for the jack lift. So as I've already mentioned, you can do this either as a single assembly, or you can do this as an individual file. So I'm going to take the individual files and drag them in. I've got these loaded already in my downloads. And here you'll see base, wedge, and wedge screw. So I've got those in my jack lift folder. My next step here is I'm going to go ahead and create a new assembly, and I'm going to call it jack lift. So I'll go start my Solidworks, and I've already got that running over here. So I'm going to go File, New, Assembly, OK. And the first thing it's going to ask me to do is it's going to ask me to start with the first part that I'm going to lay into it. Now this is kind of important. It's spelled out in the Word document, but it's not done in the detail that I'm going to explain it here. So what I'm going to do is I'm going to browse to where my parts are. So I will go to, in this instance, I'm going to go to my desktop, and I'm going to go to my jack lift folder, and I'm going to select the base. I'm going to open that. You'll notice that as I drag this part in, you'll see it flopping around or floating around. You're also going to notice that I could reorient this if I so choose. Let me maximize this. I can change the orientation of this part quite readily. And you'll see that I can either use the button that floats around, or I can right-click on it and rotate it. And I'm going to right-click and rotate in the Y-axis. I basically want to reorient this so that it appears as it does in my document. So you'll see that I want the back of it facing to the right or along the x-axis. So I've got that shown right here. So let's go ahead and orient this part. And there it is oriented. And instead of clicking, what I want to do is I want to come up here and I want to select Begin Assembly and use the check mark. What that does is places the part places the part at the origin instead of willy-nilly anywhere within the model assembly. So I click on that check mark, and that does two things. The first thing it does is it fixes the part. So you'll see that little F showing up there in the design tree along with the part name. It means the part's fixed. So when I grab it and try and move it, it doesn't move around. Now that's kind of important. And if I actually view the origin, you can see that it is laid out so that it is coincident with my origins. And I can actually view my coordinate system here too. Okay, so I've got my first part put in there, and there's nothing really spectacular about that, but I'm going to go ahead and insert the other two components, and I'll browse to them in the exact same way. You'll notice that it remembers what folder I was in. I can select both of them by holding down the Control or the Shift key, open them, and I get two different pieces coming in. There's my first piece, which was the wedge, and now the wedge screw. Both of those are inside of my model now. Now notice that I've got a minus symbol in front of the wedge and the wedge screw over here. And what that means is they're not constrained, and they're floating around essentially. This object is constrained because I've fixed it. So the first mate that I want to do is I want to mate, and I go to my Mate tab underneath Assembly, or my Mate button underneath my Assembly tab, and I'm going to pick the shaft right here, this shaft, and I want to mate it to the wall. Now you're going to notice that it may mate either an inside or outside mate. And it's kind of hard to see, so you can grab actually grab the piece, maybe. Now it doesn't want to move here for me. Let me hit escape once. Let me drag this piece a little closer over here so you can see it. Do that same mate. Mate to the shaft, to the wall. Now that's a little better depiction. Now you're going to notice that if I click the arrows, I can choose which side of the wall, whether I'm aligned or counter-aligned. So you'll see right down here, I've got those aligned and counter-aligned buttons. So I'm going to go ahead in this instance and I'm going to select my anti-aligned. Now what that did was tied this bolt shaft so that it now has to stay aligned with the wall, tangentially aligned with the wall. So that's good. Let's go ahead and do another mate. Let's pull this back a little bit and let's mate this face to the face of the base. And I'm doing a coincident mate. You'll see right here. You'll also see up here. I could change these to parallel, coincident, perpendicular, but I want coincident. Same thing with the alignment. I can change my alignment to aligned or anti-aligned. And I want to go ahead and choose the anti-aligned, meaning that they're facing each other. And select it. Now what I've done is I've constrained this bolt. It really only moves up and down. I'm going to leave that motion in it for now. Let's do a next constraint. Let's go ahead and mate the shaft and the hole. And I want to make these concentric. Now you'll notice that I've got a locked rotation option here. I don't want to do that just yet. You'll also notice what I've been doing is I've either been clicking the check mark here in the upper left hand corner, the check mark here underneath the mate box, or the check mark in the floating toolbar. I'm going to use that check mark. Now you'll see what happens is I'm now aligned so that the shaft stays aligned with the hole no matter where I move it, up and down. Now let's add our last mate between the bottom face of the wedge, and you'll notice that there's a sloped side on each side of that wedge. Doesn't really matter which one you picked. I picked the bottom one. And the face of our base, the top face. I've got a concentric alignment. And I'm going to go ahead and select that. Now you'll notice what happens is this stays concentric. Now as it moves up and down, obviously that hole moves up and down because it is a wedge. The last mate we're going to do is we're going to go ahead and mate the face of the base and the wedge, except this time I'm going to place a distance constraint in here. So my cursor's flashing. I'm going to select that distance, and I'm going to select the Advanced Mates tab because I want to give a minimum distance of 0 and a maximum distance of 2 inches. And this is just a sample of what this will do for you. So I gave that a 0 to 2 distance, and you'll notice now that it's got a limited range. Limited range. Now you'll also notice that this shaft spins. It doesn't really do anything. My wedge moves up and down as the bolt moves up and down. So let's exit out of mates. And now you're going to notice something. You're going to notice two things. First of all, that it says underdefined in my assembly. The second thing is when I come over here and look at my design tree, I've got these minus symbols. What those minus symbols mean is that the part's not fully constrained. And what's not fully constrained in this model right now is this rotation. So remember when I made that concentric mate, I can expand all of my mates here and come down and look. And I can see that that concentric mate is allowed rotation. So what that is a translation about the x-axis that's not constrained. So let's go ahead, right-click on this, and you'll see that I can either edit the feature, and I can click lock rotation here, or I can right-click and click lock rotation. As soon as I do that, you'll notice that my model resolves, my assembly resolves, and it's fully defined, and I can no longer rotate that. Now you may or may not want that bolt to rotate. I'll show you another way in the future how we can do that, give it a limited range of motion. So I can give it a 360 degree rotation also. So if I unlock this, I can go back in here and edit my feature. And I can give it a limited range of rotation between the, get out of that, between the face here. So I can give it an angle that it will turn, 360 degrees. Then it looks like it turns. But for now, I'm just going to lock it. All right, what we want to do with this is save it. And we're going to put it in the jack lift, and I'm going to call this jack lift. Now remember that assembly really is only an association between the parts, so I highly recommend that you keep all the part files in the same folder as the assembly. That'll avoid you a lot of heartache in the future. Okay, so the next thing that we want to do is we want to evaluate this particular model. So if we look up here and we go to our Evaluate tab, in interference detection, what this is going to do is this is going to tell us where do we have parts colliding. And we have a part colliding here on purpose. So you see I've got the selected components. I could actually choose different components. And I can say, hey, let me pick all of these components. So I've got the wedge screw, and the base. And once I've got these selected, I'm going to click Calculate. And you'll notice you heard that little noise in the red highlight. That red highlight shows up because I've got this Make Infringing Parts Transparent. And that lets me look inside the part. So you'll see that the shaft is impinging upon the wedge. And your question is, why do you suppose that is? My hint to you is to look at the dimensions of those particular components. And you'll probably see that the shaft's a little too big for the hole there. So what they ask you to do is to take a screenshot of this. So to take a screenshot, use your snipping tool. New. Get your screenshot. Paste that into your engineering notebook with that synopsis of why that is occurring. That's it for the jack stand. Thanks for watching.